Hi, welcome back to our class. We have this question to solve. If it takes 5 hours to drain a container of 540.0 meter cube of water, what is the mass flow rate of water from the container in kilogram per second? The density of water is given to be 1000 kilogram per meter cube. The question was torn from a topic in physics called fluid dynamics. The you can or for simplicity you can call it fluid. The subtopic is flow rate. The flow rate can be defined as the speed at which fluid passes out from a container or a vessel or a channel. So then we have two types of flow rates. We have the mass flow rate, we have the volumetric flow rate. This question, for this question, we are limited to only mass flow rate. Now, the next thing you ask yourself if there is any relation, any formula that you can use to arrive at your answer. Yes, of course there is. There is. Now let's go. Solution. Put your solution here. So for the mass flow rate is equal to there's rho, that's the unit of density, multiplied by the velocity, multiplied by that's the area of the vessel or channel, vessel or container, whichever one. That is one relation. There's another formula which is mass divided by time. But just remember, whichever one you use, whether the first one or the second one, the SI unit is always in what? Since it is mass per time, that is a kilogram per second. Now, the another question that you need to ask yourself is that, okay, which of these relations am I going to use? Which of them is suitable for us to be able to arrive at our answer? So to achieve that, you need to list out the parameters of what we are given. Remember, we are given time. Time is equal to 5 hours. So you convert that will be 5 multiplied by 60 times 60. So as a smart student, just pick the weak numbers, the 5, 6, and the 6 here. 5 times 6, 30. 30 multiplied by 6, that will be 180. Then you return the 2 is 0. 1, 2. So that is that. Then you have a that's 18,000 seconds. So that was that. What were you given again? This volume. Given volume, that would be 540.0 meter cube. What were you given again? We are given the density. That is rho. That would be 1000 kilogram kilogram per meter. So you can see we all want to do is that want to choose the appropriate formula. If you want to settle for the first formula, you can see you are giving rho. So the density you are giving, were you giving velocity? Of course, you are not giving velocity. So because of that, you will be incapacitated. So you can't use this formula one. The mass for second one, mass, were you given? Yes, you are not giving mass also, but you are giving something that will lead you to that mass. So because of that, using formula 2 will be easier for you to get to your destination than using formula 1. Now here we go. Let's look for our mass. Our from the relation density is equal to mass per unit volume, making your mass to be the subject of the formula. So mass will be equal to rho multiplied by volume. Then therefore, I will have my mass to be 1000 multiplied by 540 multiplied by 540, that will be 5, 4, 1, 2, 3, 4. 1, 2, 3, 4. Yeah. 2 bags of yam? No, that should be in kilogram. So that's 540,000 kilogram. That is the mass of the water inside that container. Now, over to mass flow rate now. Mass flow rate will be mass per time. That will be the whole of this divided by time. What's your time? That's 18,000 seconds. So 5, 4, 1, 2, 3, 4. 1, 2, 3, 4 divided by 18. How many zeros? 1, 2, 3. That's 18,000. 1, 2, 3. 1, 2, 3. 1, 2, 3. You can see the zeros are cancelling out. 18 here, 1. Here we have 3. Then you had the single zero. Ladies and gentlemen, brothers and sisters, honorable viewers, the mass flow rate of this container is going to be 30 kilogram per second. So it means that 30 kilogram of the water in the container will be leaving the channel or the vessel in 1 second. So that is the flow rate of the container. Thank you very much for watching. See you in our next video. Woo!